Okay, in this video we are going to do a little comparison between lists and arrays. I'm not going to mention any names, but a certain student of mine thought it would be a good idea for me to do a little review of the differences between those two things. And quite frankly, it is probably a good thing because in many cases students do get a little bit confused when it comes to how arrays and lists work. All right, so let's go through a couple different things in this video that kind of show and highlight the similarities and differences between lists and arrays. Okay, now first off, when we talk about a list versus array, we really need to specify that we're dealing with a capital L list. This is indicating that we're dealing with an interface called list that's provided to us by Java. That is not the same as a lowercase l list because an array is a list of things. It's a lowercase l list of things. But what we're really trying to do is look at a comparison between the lowercase l list, the array, and a uppercase L list that comes from the Java interface list. All right, so let's first get started with some declaration and instantiation. All right, this is really important because on the AP exam you're most likely going to have to do this at some point, so it's important to kind of understand the difference between the two. So let's start with the array because that's probably something that we learned initially. All right, and I'm going to use strings for this illustration. I could use a primitive type for arrays only. That wouldn't work for the list. Rather than a primitive type, I'd have to use the wrapper classes, but I don't want to delve into that in this particular video. So we're just going to stick with strings because I can use both, or I can use it in both of the types of lists that we're dealing with. So the first thing I'm going to do is declare an array. So when we do that in Java, we're going to specify the type. The type that I'm actually specifying is a string array, an array of strings. So I start with the type, and then I put brackets there to indicate that it is an array of strings. Now this is indicating that it's going to be a one-dimensional array. If I had multiple dimensions, I'd add additional brackets. So this would be a two-dimensional array. This would be a three-dimensional array. All right, so I'm just going to stick with a one-dimensional array because a list, the capital L list is one-dimensional. Then we give it a name. I'm going to say, I'm just going to call it array. And then that's the declaration part, and then we instantiate or we create the array. So we're going to say new, again, string with brackets, but this time I need to specify a size. Remember, arrays are immutable. They're going to have a fixed size, and you need to establish that size as soon as you instantiate it. It's one of the inflexibilities of the array, which causes us to use the list, the capital L list. All right, so I'm just going to say this is of size 5. All right, so that's how we declare and instantiate an array. Now, what about a capital L list? Well, there's actually quite a few different types of lists because a list is an interface. So if we were going to specify to Java that we're going to create a list, we would start with list. And then what we would do is we would instantiate it to a specific type of list, something that implements the list interface. So let's just take a look at that. I need to actually import this because it's not in java.lang. It's in java.util. All right, that's the package it's in, java.util. So the interface is called list. I'm just going to note that. This is the list interface. And the list interface defines several methods that anything that's going to be of that type is going to have to define or implement. The one particular type of list that we have seen is the ArrayList. All right, so I'm also going to import that, java.util.ArrayList. So the ArrayList class implements list. Okay, so an ArrayList is a list, but the list is an interface. So the list interface just has methods that are defined that must be implemented by whatever class implements it. And so the ArrayList is one of those. So when I'm declaring and instantiating a list, I can do so generically in the declaration. So I could say, hey, I'm going to create a list although I do need to specify the type of item that's going to be in it. So a list of strings. Okay, so we do that inside those angle brackets. And then I can just call it something, so list. But when I instantiate it, I need to instantiate it to be of a specific type of class. So what class am I using that implements the list interface? All right, so I'm going to implement that. I'm going to instantiate that with the ArrayList. So I'm saying a new ArrayList of type string. And then inside the parentheses, I pass along nothing. It has many constructors, but the only one that we've really seen before is the one that has no parameters, the default constructor, and so that's just going to create an empty list for us. Okay. Now, the reason why I declared it that way is just because I want you to be familiar with the fact that the array list is a list, and list basically just defines several methods. You may see that on the AP exam. They may tell you that something is a list, but they may not tell you that it's specifically an array list. You don't need to worry about that. But if you ever need to create one yourself, you can go ahead and create an array list. So I could declare this as type array list. That's perfectly fine. But I'm just gonna leave it as list. That will limit now list to only those methods that are found in the interface. Okay, so that's the declaration and instantiation of the two. Some nuance to the list. But it's very flexible because it's not immutable, right? It's going to grow or shrink as necessary. All right, now how about adding items? How do we add an item to an array? Well, when we add an item to an array, we really can only go about it in one particular way. We have to specify the index. So let's say I want to put something in the list at the very beginning. I'm going to access that specific index. All right, that's index 0, and then I'm going to set that equal to something. Now I don't have anything in that, so I'm going to just type a new string, and I'm going to say hi. Okay, that's how I would add an item. If I wanted to append an item in an array, I really need to be aware of the indexes. All right, the array is just kind of raw; it's just given to us. We know the structure. And anything that we do with it, we have to know the inner workings of that array. We have to maintain indexes. We have to be very aware of what's going on in that array. So if I wanted to append something to this, I need to be aware of the fact that I have something in index 0, and now I'm going to add something to index 1. And I'll just put hello. Okay, so that's how I would add an item. I have to be very aware, again, of the length of the array because I don't want to go out of bounds. If I said something like list 5 equals new string, that's going to be a problem because when I go and run this, let's go ahead and compile and run that, I'm going to get an index out of bounds exception. This is an error that Java throws that indicates that I used an index that was out of bounds. Oh, and I also see, and hopefully you were following this, Mr. Burris, you were not doing this right. This should have been array. So let's change that. Let's go back. There we go. All right, now that's much better. Let's compile that. We should now see that everything was fine except for that assignment into the array at index 5. There we go. Good. So we have an array index out of bounds exception. Index 5 is out of bounds. So I have to be very aware of the limits that I have in my array. All right. Now, the array provides me with a way to safeguard against going out of bounds, and that's by giving me a property, a variable called length. All right. So if I wanted to, I could do a system.out.println array.length. Okay. Now, it's important to remember that there's no parentheses on that because it's not a method. An array isn't really a class. It's not really an object. It is in some way, but it's an abstraction to us a little bit. We should think of it almost like a primitive type, even though it's not. It's a construct of primitive types, and that construct gives us one property called length that we can use to indicate how long it is. But it's a constant property. It cannot be changed. All right, and it is not a method. So if I do print that, I should be able to see that I have a length of 5 in there. And the compiler is taking a little bit of time here this morning. So you could fast forward. There we go. It's 5. All right. So we have no errors here. All right. Now, what about adding an item to a list? Well, the list interface provides several add methods, and we can use those with the ArrayList. All right, so I could say list.add. One way to do that is to use the add method, which is going to basically add an item to the end of the list. So right now I have nothing in my list. I have some things in my array. Now I'm going to add them to my list. So I have nothing in my list right now. So what I'm going to do is add a new string. And I'm just going to use hi again so that they're kind of in the same spots. What list.add is going to do is it's going to take my new string that I gave it and it's going to append it to the end of the list. And this is nice because I don't have to be aware of what indexes I'm dealing with in my list. Remember, it's an abstraction to us. We don't have to worry about that. It pulled some details out of that for us. But I have to add it through the method, right? I can't access it like an array. I have to add that item through a method. So that's one of the add methods, but the add method is actually overloaded, which means that there's a second version of it with a slightly different signature. The next one allows me to not only pass along a new string, but also allows me to specify an index. So if I know exactly where I want to insert a string into my list, I can specify that with an index. I do have to be careful though about this index that I use. I don't want to use something that's out of bounds. Now the array list does give you a little bit of flexibility there. The only out of bounds index you can use is the next available one. So technically right now this new string that I added is at index 0, and that's the only valid index in my list. But I could use index 1 because it's the next one. So I could use that. So if I could say that I want to add something at index 1, and I'm going to add a new string, and we'll just mirror what we did in the array, I could add hello. That will be permissible. So if I run that, I shouldn't get any kind of errors. I'm not going to see the effects of adding that to the array just to the list just yet. But we can see here we have no errors. If for some reason I try to put that in index 2, that's going to be a problem because the array list is like, wait a minute, no. That's like going way beyond what I could do. All right, so there we can see we have an index out of bounds exception there. The next available index is 1. It would allow us to use that, but it's not going to allow me to use the 2. Now, adding it in index 1 is going to be the same as just appending it. So I could have used either one here. The important thing to remember here is that the array list will actually expand. So if I add an item here, now let's try, if I add something at index 1, a new string, let's say hola. This is now going to insert hola at index 1. Well, hello was already there. So what's going to happen is this is going to basically squeeze hola in at index 1. It's going to push hello down to the end. All right, so it's actually would be a good idea for us to take a look at what that looks like. So let's print the list as well as we run this. And as we print that, we should be able to see that we have hi, hola, hello in that order. Okay, hi, hola, hello. So hi was added at index 0, hello was added at index 1, but then I inserted. So you could almost think of this second version of add as an insert. We inserted hello at index 1 and it basically bumped hello down. Now if I was trying to do that with arrays, that would not work. If I did this array, I want to insert a new array called hola at index 1 here. This would actually be a problem because what I'd essentially be doing is reassigning what is at index 1 to this new string. So hello would actually be gone. The array does not expand and shrink like the array list does. That's why we use the array list, because it's so much more flexible. All right. In addition, one of the other things that the array does not do while we're on the subject is it does not print well either. So if we go ahead and run that and we try to print the array, we'll notice that it doesn't print well like the list does. And here we go. So we can see here that what we have is something that says ljava.lang.string, and we have some code there. That's not going to really mean a whole lot to us. All right. So that is a little bit of a difference between how they add and print. Or if we wanted to print the array, we'd actually have to use a loop in order to do that. All right, accessing items. How do we access items in an array and a list? Well, to access an item in an array, we just use the indexes. All right, so if I wanted to print what was at the second spot of the array, I need to specify the index of 1, and we use the brackets there. If I want to get what's at index 1 in a list, I'm going to use the method that allows me to get that item, and that method is called get. Get accepts an index. The indexes work the same way as they do in an array. All right, so if I want the second item, or the what's at index 1, I'm going to pass along index 1. So we should see, if we run this, that we are going to get Ola in both cases. All right, and that would actually demonstrate that what we did here overrode what we had up here. Okay, so there we go, Ola, Ola. So that's all we need to do in order to access an item. All right, what about removing an item? Removing an item is tricky with an array. We can't really remove items because it's immutable. Now, what does that mean? Well, again, it's not so much that we can't destroy the values within the array. We just can't alter its structure. So if I remove something from the array, the item itself will be removed, but the structure of the array will remain the same. So let's say I want to get rid of Ola from the array. Well, I could do that by overwriting what was there. I could do something like array at index 1 equals something else. I could replace it with something else, but what if I just didn't want anything in there? Well, I'd have to figure out what to put in there that would fit the array. Is this an array of integers? If it is, maybe I put in a 0 or a -1. I don't know. It would really depend on, well, what indicates to you that there's no value there. With strings, I can't just like remove it. I can't just take it away. But what I could do is I could replace it with something. Since I'm dealing with an object, I would probably put null there, and that would indicate that there's nothing there. All right. But what about an array list? Well, in an array list or a list, we can remove an item several different ways. This method is actually overloaded. The one method that's tested on the AP exam, which I would encourage most of you to focus on, is the remove method accepts an index. I think that's the best way to utilize the remove method. There are others, and a lot of students get trapped into sending the object along to be removed, but that can actually have some side effects that you're not aware of. So don't send the object to be removed, just send the index of the item to be removed. So let's say I want to remove what's at index 1. All I do is I say remove index 1. Now what that's going to actually do is it's going to alter the structure. So unlike the array, the list structure is now going to be different. I had 3 items in that list. When I remove the 1, I'm now only going to have 2 items in the list. Okay, so I can actually prove that by printing out the size of the list. All right, to print out the size of the list, we're going to use the size method. So it provides us with a method called size, and that's going to give me the size. Unlike the array, which is a property called length. I took that out before, okay? But we can actually print that out. So we can say system.out.println. Let's print out the array length. We'll remove something from the list, and then we'll print its size. So what we should see is the array's length has not changed. It should still be 5, even though technically I took an item out. Whereas the array list now has reduced itself in size. All right, it's now 2. Okay, so that's how that works. All right. Now, one other thing about the remove method in the list is that it actually returns to you the item removed. So you could store that if you wanted to. So I could say string removed equals that, and then I could actually print that out if I wanted to. Now I could throw that right into the println statement, but just say, for example, I wanted to hold on to that removed item. I could do that. So now when I run this, what should be stored and removed is that item that was in index 1, and we can see that there, hola. All right, so it does do that. Now what about traversing? How do I traverse through a list and an array? Well, there's a couple different ways. You could first use traditional loops, and they're actually going to look fairly similar. So let's just do the array first. I'm just going to create a for loop. I'll go from I, starting at 0, while it's less than the length of the array, right? So here I'm going to use array.length, no parentheses, and I'm going to increase I by 1, and we'll just do a system.out, println, array, and then to access the item again, I'm going to use the brackets at index I. For the list, I'm going to do something very similar. I is going to start at 0. I is going to go while it's less than the size or the length of the list. In that case, I'm just using list.size, I++, and then I'm going to print out what's in the list at that particular index, but instead of using the brackets, I'm going to use get. So get I. Now it's important to remember to use get when you're dealing with a list. They do actually take points off the AP exam if you get these notations confused. So it's important to keep that in mind. So there's really not a lot of difference here. You've got the length of the list that you're dealing with. If it's an array, you're dealing with the array's length property, no parentheses. If you're dealing with the length of a list, we're actually looking at the size method. All right, the size method is going to provide us with that list, or that length rather. So if I run this, I should be able to see everything that is inside of both of those lists. So you'll see the array here. I'm starting with high, and then I have a null, 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 null. All right, it's 5 items. The first item is high. I nullified the second item, and then the last 3 I never even touched, so they're by default null. So there's nulls in all of them. Again, they have to have something in them because there's 5 items. Right? The structure is immutable. It's not going to change. Whereas in the list here, I just have the 2 items that were in there. Hi is in the first spot. Hello is in the second spot now because I did remove hola. So now it's in the second spot. All right, so that's easy to traverse. Now you can also do this with the new for loop, or what I like to call the for each loop. So we can take a look at how that would work. So we're going to loop. I'll do the array first. We're going to loop through the array. So we have to just think about what kind of values are in the array. So I have strings in the array. So for every string, and then I need to give it a name, string what? We'll just give it a name S, in colon, and then the name of the array. So for every string S in array, that's how we would read that. For every or for each string S in array. This time through the loop, what we can do is just print S. Okay, we're not accessing the item because that's actually what the loop does. I'm going to just take these brackets out because I only have one statement. We don't have to access the indexes. The loop structure kind of abstracts that all from us. It's just every single time we go through the loop, S is going to be the newest item in the list. So it's just going to start from beginning to end. I can't control the beginning. I can't control the end like I can in the for loop. It's just going to go from one point to the end. It's just traversing it from beginning to end. I don't know what index I'm at in the context of the loop. I just know that each time through there's going to be a string called S, and it's each string that was in that array. All right, we can do the same thing with the list, so we'll do that. This list, we have to be aware of what's in it. Well, this also has strings. So string, for every string S in, well, what's the name of the list? It's called list. I'm going to take that out, and then we are going to pretty much do the same thing as we did for the array. All right, so you notice that there's not a whole lot different here. We're just using these two. All right, and we can use this special for loop because these things are traversable. So we can That's what these are for things that can be traversed from beginning to end. All right. You might call them iterable as well. So if I run this, I should get duplicate entries each time for the array and the list. Oh, we have a little bit of an issue, and that's because I missed an L here, which you probably caught if you were following along, right? You probably said, oh, Mr. Burris, you missed that L, you're going to have a problem. You were prophetic. All right, there we go. So here's the printing of the list. We have hi, null, 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 null. And then again, we have hi, null, 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 null. And then in the list, we have hi and hello, and then hi and hello. Again, just the one thing to be aware of, you are not aware of your indexes, so don't use this new loop if you need to do things like figure out where you are in the list or compare things to the next item in the list. Or also, you don't want to use this if you're removing items in the list. You can't do that, all right? If you need to remove or things of that nature, you want to be using the traditional loops. All right, so that's a little bit of an overview of the difference between lists and arrays. Hopefully that is enough to solidify some of the thinking or some of the learning that you've had over the course of the year. There are many other methods that we can use in the list, but we don't really have an equivalent to them in the array list, so I don't really want to delve into them here. All right, hope this helped.